Welcome to Artificial Intelligence Bytes. I'm here to walk you through one of the most fundamental challenges in machine learning, overcoming underfitting. Looking at the visualization in front of us, we can see the classic learning curves that every data scientist needs to understand. Notice how both the high training loss and validation loss start elevated and gradually decrease. This is the signature of an underfitted model. What exactly is underfitting? Underfitting occurs when our model is too simple to capture the underlying patterns in our training data. It's characterized by high bias and low variance, meaning our model makes strong, oversimplified assumptions that consistently miss the mark. The graph clearly illustrates this phenomenon. When we see both training and validation errors remaining high throughout the training process, we're dealing with a model that lacks the complexity to learn the data's true relationships. How do we diagnose underfitting? Unlike overfitting, underfitting is relatively straightforward to detect. The telltale signs include poor performance on both training and test datasets, and learning curves that plateau at unacceptably high error rates. Now, let's discuss solutions. The image shows us several key strategies. First, increase model complexity. Transition from linear to nonlinear models, add hidden layers to your neural networks, or incorporate polynomial features. Second, enhance your feature engineering. Add relevant features that capture important patterns your current feature set might be missing. Additional techniques include reducing excessive regularization that might be constraining your model too heavily, collecting more diverse training data, and extending your training duration to allow the model more opportunities to learn. The neural network diagram in our visualization reminds us that architecture choices matter significantly. Sometimes the solution is as simple as adding more neurons or layers to increase your model's representational capacity. Remember the bias-variance trade-off. While we're addressing high bias through increased complexity, we must monitor variance to avoid swinging too far toward overfitting. The goal is finding that optimal balance where our model captures true patterns without memorizing noise. For practical implementation, start with baseline complexity and gradually increase it while monitoring both training and validation performance. Use techniques like cross-validation to ensure your improvements generalize well to unseen data. Mastering the identification and resolution of underfitting is essential for building robust, production-ready machine learning systems that deliver reliable predictions in real-world scenarios. Thank you for joining today's exploration of overcoming underfitting. Subscribe to AI Bytes for more fundamental machine learning concepts that drive successful AI implementations.